Okay, so we're going to talk about something called functions defined by integrals. When you immediately look at them, one of the first things you're going to notice is that you're going to notice that you see an x in an integral. But this is different from second FTC because, guys, there's no d dx or derivative of this thing. So it's really important that you understand what it is you've been given and how you connect to the pieces. So I've got some function, which we're going to call that function f, and f is consisting of a quarter circle and some line segments. And what we know is that this function looks like this: the integral from 0 to x of f of t dt. Now, what we want to be able to do is to answer some questions about this function. So the first thing it asks you to find is g of 0. So in order to calculate this, I'm going to find the integral from 0 to x, but instead of x, I'm going to put a 0 right here, because basically all I'm doing is I'm replacing the x where the x was. So what is this actually saying? Now look at your graph. You have the graph of f. I want the integral from 0 to 0. Well, you know, because you know your properties really well, that the integral from 0 to 0 is 0. Okay? So let's do another one. Now I want to find g of negative 1. So that's going to be the integral from 0 to negative 1 of f of t dt. Now you're going to notice that that's technically not in an order that we have been taught. It should go from low to high. So I'm going to rearrange this to be the integral from negative 1 to 0, and we're going to throw a negative sign in front of it because I've switched the order of f of t dt. And so if I have the graph of f, again, all this is saying is find the area from negative 1 to 0. So that's basically the area from negative 1 to 0, which is just my triangle. I'm going to still bring my negative sign, and now using the area formula, 1/2 base of 1, height of 2, and my area ends up being negative 1. Okay? So I'm going to erase this, and we're going to answer 2 more. So make sure you have these copied down. Okay? So now let's find g of 2. Again, all I'm doing is replacing, instead of x, which is located right here, I'm going to put a 2 where x is. And this is saying that this function g is the area under the curve of f. So the area from 0 to 2 is my semicircle that's over here on the right-hand side. So area of a semicircle or a quarter circle would be pi r squared, but instead of cut in half, it'll be cut in fourth because it's a fourth of the circle. And I can clearly see that the radius is 2, so pi 2 squared over 4, which is going to give me a value of pi. Okay? So then the last question asks me to find g of 5. So that's going to be the area from 0 to 5. Again, I'm replacing the 5 where the x is of f of t dt. And so now using my area, we already know that the area from 0 to 2 is pi. And I now need to pick up this area, 3, 4, 5, which is all of that. So I'm going to break this up and say there's another triangle. So 1/2 base of 1, height of negative 2, and then picking up this part right here, which is a trapezoid. 1/2. B1 looks like it's 2, B2 looks like it's 1, and it has a height of 2, and technically I've got to make sure that this is also negative because it's an area under the curve. So now simplifying this down, we get those 2's are going to cancel out. Those 2's are going to cancel out, so that should give me pi plus negative 1 and plus negative 3, or pi minus 4. Now, just like any other function, this function g, I can answer some questions about it, which is kind of nice. What if I want to know where the graph of g is increasing? So this is where it's going to really require you to make some connections about the fun chart, okay? Now keep in mind, it's not asking about f, it's asking about g. So we know that g is the integral from 0 to x of f of t dt. That means that if I want to know where the graph is increasing, I need to know about g prime. Well, g prime is going to be the derivative of the integral from 0 to x of f of t dt. Now, because you just learned second fundamental theorem of calculus, you know that the derivative of an integral is just f of x. So now, if I want to know where the graph of g prime is increasing, or the graph of g is increasing, it should be where g prime is positive, which since g prime is equal to f of x, it's going to be where f of x is positive. Well, what's really nice is that you have the graph of f of x. So now go up here and look at the graph of f of x. When is the graph of f of x positive? Well, the graph of f of x is positive right here. So from -1 to 2. So now I can make the conclusion that g is increasing from -1 to 2, and to justify my answer, it's because g prime, which is equal to f, is positive. Okay? So now let's make some further connections. Find all values of x in which g has a relative maximum. So guys, let's empty our brains about what we know. We know that a relative max occurs when g goes from increasing to decreasing. If g is going to go from increasing to decreasing, that means that g prime must go from positive to negative. Well, what did we just discover that g prime was? In our previous example, we discovered that g prime was equal to f of x. So now I can say that I'm really going to be looking for when f changes from positive to negative, which I can go up to my graph and see that it's going to change from positive to negative right here at 2. So I can make the conclusion that there is a relative max at x equals 2, and to justify my answer, because g prime goes from positive to negative. But it might be worth noting that g prime is equal to f. Okay? Now, what about the absolute minimum value? The absolute minimum value. Okay? Now, you need to remember that anytime you're asked about an absolute, your brain needs to immediately go to candidates test. So, looking back and thinking about this, all of your candidates are anywhere where g prime equals 0 or endpoints. Well, remembering that g prime is technically equal to f, where are all the places that f equals 0 or endpoints? So we're going to make a table of values. Okay? Our endpoints are -1 and 5. Places that f, or g prime, equals 0 happens to be, go up to your graph, f equals 0 at just 2. So we're going to put 2 right here. Now what will we plug into? We're not going to plug into f, we're going to plug into g of x. Now, what is g of x? Remember that g of x is the function integral from 0 to x, f of t dt. What's really nice is if you go up and look at letter A, which you've already answered, all of these are in letter A. Let me give you an example. This is the integral from 0 to -1 of f of t dt. Well, we already answered this. The integral from 0 to -1 we discovered earlier was -1. This is the integral from 0 to 2 of f of t dt, which again you already answered was pi. And you already found g of 5, the integral from 0 to 5 of f of t dt, which again you discovered earlier was pi minus 4. So which of these is clearly the biggest value? Well, it looks like our biggest value, or excuse me, our smallest value should be 3.14 minus 4. It should be -1. So we have an absolute min at x equals -1. And that absolute minimum value is -1. Okay? Now what I really like is this next question. This next question kind of pieces it all together for us and makes some more ahas. When is the graph of g concave up? Well, if I want to know when the graph of g is concave up, I need to know about g double prime being positive, right? Well, let's think about it like this. We know that g is the integral from 0 to x of f of t dt. We discovered that g prime was the derivative of the integral from 0 to x of f of t dt, which, because you know FTC, second FTC, you know is just f of x. Well, what that tells me is that if I take one more derivative, g double prime is f prime of x. So basically, I want to know where is f prime of x positive. So now, what is f prime of x? F prime of x is the slope. Look at your graph of f. When is the slope positive? Well, let's trace it with our highlighter. The slope is positive from -1 to 0, and also from 3 to 5. So that tells me that since the slope is positive at those points, my graph of g is concave up on -1 to 0 and 3 to 5, because g double prime, which is equal to the derivative of x, is positive. Okay? So then how will I find a point of inflection? A point of inflection is where your concavity, g double prime, changes sign. Well, g double prime is equal to f prime, so f prime must change sign, which basically means that f prime needs to go from positive to negative. So I'm going to look up at my graph and find the place where my graph goes from increasing to decreasing. So when does f go from increasing to decreasing? That happens at 0 and at 3. So there is a point of inflection at x equals 0 and at x equals 3. So I'm going to take you through a couple more examples and then finish out. I don't know that we'll go through this whole page or not, but I want to give us enough room so that you guys get to try some of these. So here's what we've got. I've got a graph, excuse me, not a graph. I've got a function f of x, which is a function defined by integrals because it has an integral in it. But I want to know, where is f decreasing? Now, in order to know where f is decreasing, that means I need to know where f prime is negative. Well, that means I need to take the derivative of this expression, which means we're going to throw a dx in front of this integral from -1 to x of t plus 2, t minus 3 squared dt. And because I know second FTC, I know the derivative of an integral means that this thing is going to become x plus 2, x minus 3 squared. And that is f prime of x. If I want to know where this is negative, that means I need to set this equal to 0. And I get 2 critical points. I get -2 and +3. Make sure you label your number line. We're going to check some points and find out that it should be negative, positive, and actually positive. Because I'm taking this, and remember, I'm plugging this into the derivative. Well, what does that tell me about f? That means that f is going to decrease, then increase, and then increase. So now I'm ready to answer my question. F is decreasing on -infinity to -2. It didn't say justify the answer, but I could justify my answer by saying that f prime is negative. Okay? I'm going to walk you through at least 2 more, and then you guys are going to try one. So in this next example, I have a function defined by integrals, but it says, it's kind of goofy, you've got 3x squared minus 12 is equal to this big gross thing, and it wants to know what is f of x. So, kind of weird, but here's what we're going to do. I want you to take d dx of both sides. Now watch what's going to happen. If I take the derivative of the left, I get 6x. If I take the derivative of the right, I get f of x is equal to 6x, which is kind of cool because that's what they asked me to find. It then says, find the value of c. Find the value of c. So here's what we're going to do. We have 3x squared minus 12 is equal to the integral from c to x of f of t dt. Well, guys, now that you know what f of x is, we're actually going to say, instead of f of t, I'm going to say 6t right there. So basically, all I've done is I've taken this function right here, and I've replaced the x with a t, because it says that it should be f of t. dt is equal to 3x squared minus 12. Okay? Well, you know how to take the antiderivative of 6t. The antiderivative of 6t should be 3t squared, and we're going to evaluate that from c to x, which is going to give me 3x squared minus 3c squared. It then becomes obvious that I can cross through my 3x squareds and get that negative 12 is equal to negative 3c squared, or 4 is equal to c squared, so c must be equal to positive or negative 2, which is kind of cool. All right, let's do one more. So this one's kind of interesting because this question, I've been given the integral from -2 to 5, and I've been asked to find kind of a transformation of that. So what we're going to do is we're going to break this apart. First thing I'm going to do is I'm going to pull the 3 on the outside from -2 to 5 of f of x dx. And then I'm also going to say minus the integral from -2 to 5 of 2 dx. Okay, this is not using functions defined by integrals per se, but we already know that this right here is 4. So I have 3 times 4 minus, well guys, what's the antiderivative of 2? The antiderivative of 2 should be 2x, and we're going to evaluate that from -2 to 5. So all of this should fold up to give me 12 minus 2 times 5 minus 2 times -2, close my parentheses, or 12 minus 10. That's going to end up, once I distribute that negative, to be -4. So 12 minus 10 is 2. 2 plus -4 is -2. And we're done. So what I'd like for you to try now is something a little bit interesting. You have a piecewise function for f of x, and this is not necessarily a function defined by integrals, but I want you to find the integral from -3 to 2, and this is just a review, -3 to 2. So you're going to have to break it up into 2 piecewise integrals and find the value of the antiderivative. And you should have this filled out before you walk into class next time.